All right, welcome ladies and gentlemen. This is a pretty quick video on something called percent ionization, or something also called percent dissociation. The two words are used interchangeably. And it's an additional calculation that we can do about acid-base chemistry. So percent dissociation is one of the ways that we can measure acid strength. We can say, well, what is the percentage that this acid is dissociated? Obviously, if it's 100% dissociated, then that's a really strong acid. But if it's 5% dissociated, then it's a weaker acid. Or if it's 1%, then it's weaker than the 5%. So this percent dissociation that we've been talking about throughout the year is actually something that can be calculated. And the nice thing is that it's just a percent. Like, dude, it's a percent, and we know how to calculate percent. It's just a percent of something that's in terms of acids. So all percents are part over whole times 100, all of them. And this is absolutely no exception, but it's just a question of what's the part, what's the whole when we're talking about acid dissociation. So we have an acid dissociation reaction shown here, right? HA goes to H plus plus A minus. That's our acid dissociation reaction. Well, what's the part, what's the whole? If we want to talk about the percent that it's dissociated, you'd be talking about the products. And specifically, the way that we would measure acid strength is through the hydrogen ion. So this is the part, right? How much of the H plus actually dissociated, how much of it actually split up. So what's your whole? Well, this is your whole right here, right? This is what you're starting with. That's your whole thing. So acid dissociation, percent dissociation, is simply calculated by putting your part, that is your H plus ion that popped off, over your whole. That's your HA. And it is the initial HA that you start with, not necessarily the final amount of HA that you end with. It's saying, you know, what is the whole HA that you put in the solution at the beginning, and how much of it then dissociated and turned into H plus and A minus. And then times 100. So percent dissociation. So sample question, just how we're going to see this. What percent of the acid is dissociated in a 0.1 molar formic acid solution with a pH of 2.38. We want percent dissociation, right? So we want the H plus concentration over the HA concentration times 100, and that's our part over whole. And so we just need to get those numbers. So what are the numbers that are given to us in the problem? Well, we have this number, first of all. It says 0.1 molar formic acid. We don't even need to know what the formula for formic acid is. We just need to know that that's our acid, right? That's HA. And they told us the concentration. Awesome. Boom. There's your bottom number, 0.1. It tells us that we start with this 0.1 molar solution of our particular weak acid. The fact that it's formic acid is not terribly important here. We just know that that's our acid. So we have our bottom number. Great. And then it says it has a pH of 2.38. Well, we need the hydrogen ion concentration. pH is most definitely not hydrogen ion concentration. However, pH is firmly related to hydrogen ion concentration, right? We know that pH is equal to the negative log of the hydrogen ion concentration. Cool. They gave us this number, so we can then figure out the H plus number and then get our top number. But remember, you have to know your log rules. So in order to solve this for the hydrogen ion concentration, first of all, you bring the negative over, right? Negative pH equals log of H plus. And then if you take that anti-log, you get 10 to the negative pH. Gives you your hydrogen ion concentration. Well, that's exactly what we have. We have pH. So we can do 10 to the negative 2.38 to get our hydrogen ion concentration. And you certainly never stop your calculation there. You will not leave decimals and exponents in this class. You will take the extra time into your calculator and go 10 power negative sign 2.38. And I low-key hope you're doing this right now while I'm talking, right? And you're figuring out what the hydrogen ion concentration is, because we're not going to leave decimals in our exponents. And when we do this, we get a concentration of our H plus concentration of 0.00417 molar. Cool. That's our top number. Boom, right there. So then solving it, we have all the numbers we need. We know that the hydrogen ion concentration is 0.00417 molar. We know that we started with an initial 0.1 molar weak acid solution. Multiply that by 100. And our percent ionization is 4.17%, which is right in line with a weak acid. In fact, formic acid is a bit on the strong side for weak acid, so I'd actually say this is a fairly strong weak acid. But this is definitely a calculation that you can do with acids and bases using pH. You can calculate the percent dissociation.